Paul's presented quite a lot, but still, we need a big round of applause for Paul. Paul has a lot of help. Helps us a lot in Bettakultcha York. Just trying to encouraging people to come and retweeting and sharing on our feed. So if you would all like to follow Paul's example later on, that would be most appreciated, and maybe we can get a few more people next time.
And you can pronounce my name, Richard, can't you? So,
I can, yes. Yeah, there's no, I'm fine with Paul Smith. I can do. I will get it right. It's just not straightforward. I'm from Sheffield. It's tricky. Okay, Paul, are you ready?
I think so.
Okay.
So I'm going to try and talk about maths, even though I've not got any real maths training, and I'm hoping there's not too many mathematicians actually in the audience. So this sum, which is an infinite sum, all of the natural numbers from 1 all the way up to infinity, is an amazing thing. 1 plus 2 plus 3 all the way up to infinity is equal to minus 1 over 12. So this is it's a surprising thing. I love the fact that in maths, when you get big and you deal with the infinite, you get really surprising things. I think Ron's probably right. A lot of you won't believe me. So I thought we'd do some maths and try and construct a proof in however many slides we've got left, 15, 16 slides. So who wants to do some maths? Yeah. That's a better reaction than I'd hoped for. So we're going to try and construct this. So there's here's 3 sums. The first one obviously is the one we're aiming for. S1, which is 1 minus 1 plus 1 plus 1 minus 1. And S2, the other sum we're going to look at, which we'll come to later. So this sum, 1 minus 1, so 1 minus 1 is 0, plus 1 is 1, minus 1 is 0, and actually this is something called Grandy's series, and the actual result of this is a half, and that probably makes some sense because it's either 1 or 0, so if it tends to infinity it probably tends to a half, and there's complicated proofs of that I don't understand, but you know, it's a half. So we're going to look at S2. In fact, we're going to look at this twice. So 1 minus 2 plus 3 minus 4. And we're going to try and calculate what 2 S2 are. So obviously, what we're going to do with this particular series is just move this over one so that we can add these two together. So 1 plus, or 1 minus 1 plus 1 minus 1, and here we go. What you actually get with 2s is the original, 2s2, I've managed to miss that off. So with 2s2 is actually, as you can see, it actually equals s1. So to summarise where we're at, 2s2 equals s1. So s1, as we know, equals a half. So 2s2 equals a half, therefore s2 equals a quarter. So we're getting there. We've got the original one, S1, which gave us that answer of a half. S2, we've calculated by adding it to itself and then comparing that to S1, actually gives us an answer of a quarter. So these are 2 infinite sums. So what we're going to do now is try and take S2, the one we've just calculated, away from S1. And what you can see is 1 minus 1 cancels out. Plus 2 minus minus 2 will give you 4. Plus 3 minus plus 3 will give you 0. Plus 4 minus minus 4 gives you 8. So you're probably starting to get the pattern. So S, the one we're looking for, minus S2, equals this infinite sum. Again, 4 plus 8 plus 12. I hope you're following. I'm just about following. So S minus S2 equals this sum, which actually what you can see here is you take a factor of 4 away, and S minus S2 equals 4S. It's just 4 times the original sum. So S minus S2 equals 4S. So we know S2 equals a quarter. If you remember, we had that calculated. So S, the one we're looking for, minus a quarter equals 4S. So take an s from each side, you get minus a quarter equals 3s, so s equals minus 1 over 12. So that original sum, that infinite sum of 1 plus 2 plus 3 plus 4, does indeed equal minus 1 over 12. So you might be thinking that there's some mathematical trickery, and there probably is a little bit in quite a short proof, but this actual sum is used in string theory. So these results appear in physics. It's important in string theory, and not that I've read the textbook, but this is a result that actually has some application. Thank you very much.